So first of all, in the red circle, we've got the enhanced mobile broadband. So this is the one that everybody talks about. This is just the high capacity one. And there are multiple aspects to that in its own right, and I'll cover that in a little bit more detail in a second. Fixed wireless access in the purple circle is a means to use connectivity from the mobile network directly to buildings or fixed locations. And there are some opportunities there because of the fixed nature to improve the throughput and do some things that avoid maybe the cost of digging up streets and so forth, a little bit cheaper than rolling out fiber. Then there's some other less obvious items. So network slicing is one that some of you may have heard of already. And this is the ability to take a physical network and divide it into multiple virtual networks. And they all can have their own control over that part of the network. So for example, you might partition a piece of the network for the use by the emergency services. Now, clearly you wouldn't want somebody's casual day-to-day traffic interfering with those emergency services. And using network slicing, we can do that and partition traffic away and give control over a certain restricted amount of capacity in those networks. So that's an interesting angle. It was originally designed as part of the LTE system, but it's also present in 5G. Then working across the bottom in the yellow circle, there's distributed cloud. This one's a little bit less obvious, but you'll have heard about all the discussions in the news about software and the role of governments in terms of software that might be affected in 5G. And that's because 5G has a much more software-centric approach in terms of the amount of processing that needs to be done. It's a lot more flexible and there's a lot more to it. And as a result, there's processing power at the edge of the network. And so you start to build a distributed cloud. There's a very flexible upstream downstream configuration. So dynamically, you can change the amount of traffic that's allocated to upstream and downstream and share the spectrum for the two directions. That's quite useful. And then there are two more in the blue sections, which are ones that really won't affect media very much, but do feature in the news quite a lot. So the ultra low latency reliable communications. So this is the one that's used for automotive and industrial applications, where there's a need for very fast responses and also a very high guarantee of availability and delivery. And then there's narrowband Internet of Things, and this is all about moving small amounts of data using low power. So these last two probably don't affect media very much, but the other attributes, the other 5 attributes, are fairly significant and have impacts in different ways. So let's have a look at some of the new and improved media applications that occur because of 5G. The first one we might look at is the obvious one. Now, this is the one that everybody thinks about, which is better video to mobile handsets. And it's true. The enhanced mobile broadband feature of 5G, it's greater throughput, and it comes in a number of ways, is definitely a real asset. And that tracks with the consumption trends and the content resolution trends that we've seen. But it's not just that. Because the distributed cloud part of it is coming in, what that means is we can start to visualize the possibility of having more complex processing at the edge, which is more media-centric. So, for example, we could do just-in-time packaging. We could do personalization using something like Prisma from MediaKind. We could do flow management to ensure that there's fair allocation of bit rates, and we're not just trying to use ABR in its contentious approach. So in this way, we can start to have better monetization, and also to be able to manage things like blackout, where you can't see, where you need to not be able to see adverts based on certain device characteristics, that kind of things. Like you need to be able to read text at the bottom of the screen, for example. Also to enforce geographic rights. So there are a number of things that you can do that become possible with a distributed cloud architecture. Another example of what we can do is start to look at how to better cover news and outdoor events. Today, there is plenty of news gathering using mobile coverage, and some events, sports events, are covered that way too. And as you see the graphic of cycling, it's particularly interesting because cycling today has a particular problem. The finish lines are typically somewhere that's not a fixed wired fibered infrastructure, so that the connectivity is not necessarily that great as a building. But what you do get is a lot of crowds. and they're all trying to film and see the end of the race. And suddenly, if you're trying to use the mobile network for backhaul, it becomes a problem to connect to it. So often there'll be a temporary Wi-Fi hotspot put in place for the cameras and so forth. But a couple of aspects of the 5G rollout can help that significantly. So the enhanced mobile broadband can obviously help, just the ability to have more traffic. The greater flexibility in upstream and downstream is certainly beneficial too. And then of course, the really important one, which is the network slicing. So if you are trying to cover this event, ideally what you'd want to do is avoid the ability for anybody else's cell phone coverage and uploading of YouTube clips or whatever it might be to social media to interfere with your traffic. With network slicing, you can do that. So now you can have a higher capacity throughput in the upstream direction, and you can start to put protection in place to avoid interference from other people. So this becomes a much more practical way to use it. In a similar way, we can see a move to better remote production. Many sports stadiums today, in the top tier stadiums at least, tend to have fiber connections already. So they're okay, they've already got coverage. But depending on the event and the type of sport and the stadium and so forth, some venues are not necessarily that well served in terms of backhaul capacity. So what we can do is we can start to use some of the new features of 5G. So again, the enhanced mobile broadband, fixed wireless access, network slicing, and potentially distributed cloud to improve the ability to bring back connections from stadiums that are not fibered up by temporarily putting in a fixed wireless access point into the stadium. And then we can bring back from the mobile network straight to the studio. And of course, this becomes more possible with the move to IP, and yet more so with the adoption of IP within studios, ST2110 adoption and so forth, which can then be on premises or potentially also in a cloud deployment. So there's a real opportunity here to modernize some of this contribution system. It won't be used for everything, but it's certainly going to be a means to help some of the contribution links for sports.